All right, kiddos, today I'm going to show you some more mixed gas law calculation problems. So there's 4 gas laws. I call them the ABCD gas law. A for Avogadro, B for Boyle, C for Charles, D for Dalton. Simple, ABCD. And they each come with their own equation. So the first one, let's read these. Number 1, a 14.8 liter balloon is at 255 Kelvin. What will be its volume if the temperature is 304 Kelvin? Okay, so let's zoom in here so I can work. So first off, let's look at all the information the problem gives. 14.8 liters. Liters, what is that? That is a volume. 255 Kelvin, that is a temperature. And then again, it's asking for volume, and it gives another temperature. Okay, so we look up at our equations, volume and temperature, volume and temperature. Which one are we going to use? So we're going to use Charles' law. It has volume and it has temperature. So that's the one we're using, Charles' law. Okay, so Charles' law states we have V1 over T1 equals V2 over T2. Okay, now all we have to do is figure out what goes where. What is V1? What is T1? Okay, well, the ones represent the conditions before anything changed. Before anything changed. A 14.8 liter balloon is at 255 Kelvin. What will be its volume if the temperature is 304 Kelvin? So look at these two values here, 14.8 and 255. Those are the values of the balloon before the temperature changed to 304. So 14.8 and 255, those are my ones. Those are my ones. So volume 1, 14.8 liters divided by 255 Kelvin. And then we simply plug in the remaining values. What will be its volume? So we don't know what V2 is if the temperature is 304 Kelvin. 304 Kelvin. So that's our equation with all of our values plugged in. Simple cross multiplication. Simple cross multiplication, okay? So on your calculator, it would be 14.8 times 304 divided by 255. 14.8 times 304 divided by 255. So let's work that out in the calculator. I'll give you a few minutes to do it while I do it also. 14.8 times 304 divided by 255. And we come up with 17.6. So I'm going to go ahead and erase this so I can have room to write my answer. And we come up with 17.6. What is our unit? What is our unit? It's asking us about volume. What is our unit for volume in this case? Liters. 17.6 liters. Easy as that. We figured out which equation to use. We plugged in our values in the equation, and then we cross multiplied to get our answer. Okay, so let's look at number 2. Let's read through it. Underline all your values as you're reading. Underline all your values as you're reading, just to make it easier. If 0.42 moles of helium occupies 9.9 liters, how many moles must be added to inflate the balloon to 17 liters? Moles and liters. Let's look back up at our equations. Moles and liters. Moles and liters. Which one is it? Avogadro's law, correct. Moles would be N, okay? N stands for number of moles. And then, of course, that's our volume. We calculate our volume in liters. So Avogadro's law. So V1 over N1. V1 over N1 equals V2 over N2. So remember, the ones represent your values before anything changed. Your ones are your values before anything changed. If 0.42 moles of helium occupies 9.9 liters, that's before, right? That's your initial values before anything changed. So our original volume, 9.9 liters. Original number of moles, 0.42. And we set that equal to our conditions after the change. How many moles must be added to inflate the balloon to 17 liters? 17 liters. And then we're solving for N2. And again, cross multiply. We're cross multiplying. 0.42 times 17. Okay, cross multiply. 0.42 times 17. And then the other number, that's what we divided by. We divided by the odd man out. 0.42 times 17 divided by 9.9. And we get 0.72 moles. Now be careful. That is not the final answer. 0.72 moles is not the final answer. Read the question carefully. How many moles must be added? How many moles must be added? We started with 0.42 moles. That's where we started from. And we ended up at 0.72 moles. How many moles did I add to get up to 0.72 moles? That would be our final answer. .30 moles. 0.30 moles. Always read the question carefully. They're going to try and trick you like that. How many moles must be added? We had to add 0.3 moles to get from where we started from, which is 0.42 moles, to where we ended up at, which is 0.72 moles. And I guarantee you, both of these, 0.72 moles and 0.3 moles, both of them would be answers on a multiple choice test. I guarantee you, they try to trick you like that. Don't fall for it. Don't fall for their trickery. Read the question carefully. Okay, so let's continue on. Let's look at number 3. Again, we're going to underline as we read. Okay, we're going to underline our values. The air in a syringe has a volume of 25 milliliters. When the pressure is 4.38 atmospheres, what will be the volume when the pressure is 4.65 atmospheres? Volume and pressure. Look at our equations. Volume and pressure. Which one is it? Boyle's law. Boyle's law. P1V1 equals P2V2. So that's our equation. P1V1 equals P2V2. P1V1 equals P2V2. So now let's plug in our values. Remember, the ones, that is the conditions before anything changed. Your original conditions, your initial conditions. So read the question again to figure out which values are your original values. The air in a syringe has a volume of 25 milliliters when the pressure is 4.38 atmospheres. What will be the volume when the pressure is 4.65 atmospheres? So the 25 milliliters and the 4.38, those are our ones. Those are our ones. Now, you have a choice. You can keep it in milliliters or you can convert it to liters. That doesn't matter, okay? The thing is, though, your unit for your answer, because it's asking for volume, the unit for your answer has to match the unit of the volume in the problem. So if you convert it to liters, then your final answer is going to have to be in liters. But let's leave it in milliliters. So that's our initial volume, 25, and that's our initial pressure, 4.38. Okay, so pressure, 4.38 atmospheres times our original volume, which was 25 milliliters. What will the volume be when the pressure is 4.65 atmospheres? That's our P2. And then we are solving for V2. So that's our setup. That's going to be our setup. Okay, P1 V1 equals P2 V2. So we're going to multiply 4.38 times 25 divided by 4.65. Okay, that's what we're doing. We're multiplying these two together, and then we're dividing it by that one. We're multiplying those two together and dividing it by that one. 4.38 times 25 divided by 4.65, we get 23.5. So our final answer is going to be 23.5 milliliters. Final answer. Okay, very simple. So let's look at the last one. A diver's tank contains helium at 92 kilopascals, nitrogen at 194 kilopascals, and oxygen. If the total pressure of the tank is 1,266.26 kilopascals, what is the pressure exerted by oxygen? So this problem, it just gives us one single thing. It just gives us one thing to work with. Pressure, 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 pressure. Kilopascals is a unit of pressure, remember. So we're just dealing with pressure. So which law is just pressure and nothing else? Dalton's law. Dalton's law. Very good. Okay. So Dalton's law tells us that the total pressure is equal to the individual partial pressures. There's 3 gases. So I'm going to put 3 pressures. And then from here, we simply plug in our values. The total pressure of the tank. So I have PT, total pressure. 1266.26 kilopascals. Okay. And then let's make helium P1 simply because it's listed first. 92 kilopascals. And let's make nitrogen P2 simply because it's listed second. 194 kilopascals. And oxygen. That'll be our P3. If you don't know what oxygen is, that's what we need to figure out. Okay, so look at this. 1266.26 equals 92 plus 194 plus P3. How are we going to get P3? Subtract. Simple as that. It'll be 1266.26 minus 92 kPa minus 194 kPa. That's all it is. So let's do that math really quickly. 1266.26 minus 92 minus 194. And we're left with 980.26 kPa. That's as complicated as Dalton's law is going to get. It's very simple, addition and subtraction. Okay, so you have this handout yourself. Okay, go ahead and write this down. Keep it in your notes. Look it over. Remember, your first step, figure out which law you're using. Read the problem. Identify the variables. Which law has those variables? And once you do that, plug in your numbers. The ones are before any change took place, and the twos are after any change took place. And you're just simply going to cross multiply. Multiply two numbers together, divide by the third. Watch out for your units. Read the question carefully. Alrighty, thank you for watching, kiddos, and have a good day.